Okay, so let's continue on with balancing reactions. So the first step with balancing a reaction is just like actually writing out a chemical equation. You want to determine the reactants and products, so our skeleton structure of a chemical equation. And then once you write out all the chemical formulas for those products and reactants, you don't want to change those formulas. All right, we're going to keep those the same. Then you need to take a look at all of the different things that appear on each side of the equation. So you want to take a look at the atoms, and we want to balance the atoms that are on the reactant side and the product side. And the way you do that is to add coefficients in front of those formulas. And you only want to add coefficients. You don't want to change the actual chemical formulas, like I said here in step 2. So you need to take a look at those coefficients and balance them, or change the coefficients to make those atoms balanced. And then finally, you need to check the number of atoms on both sides and make sure that that you have the same number on each side. And then add any catalysts or state symbols to your chemical equation to match what the prompt is telling you. And so the tip here for balancing reactions is that you want to balance the atoms that only appear on one side, on each side once first. And I think it'll just take a little bit of practice once you see it. So, if sodium only appears in one specific chemical formula on the reactant side, and it only appears on one place in the product side, you want to balance that sodium first. So for example, if an oxygen shows up in like 2 of your products, you want to balance the oxygen last. All right, so let's go ahead and practice turning chemical descriptions of chemical reactions into a chemical equation and then balancing them. So it's going to operate largely the same. We'll go through the sentence, figure out our skeleton structure of our chemical reaction and write it as a chemical equation, and then balance those atoms at the end. All right, so aluminum oxide metal oxidizes in air to form aluminum oxide. So what the word oxidizes means is essentially just means reacts with oxygen gas that's in the air, so O2 gas. So that's one of our reactants. All right, so if we go through the sentence, aluminum metal. Aluminum is one of our elements, so aluminum. It's a metal, so it's a solid. And like I said, oxidizes means reacts with oxygen gas, so plus O2 gas. And what it forms, so forms is essentially our reaction arrow, and it forms this product, aluminum oxide. So aluminum oxide is an ionic compound, so we need to identify it as an ionic compound and figure out what its chemical formula is. Aluminum is a group 3A metal, so aluminum will be aluminum 3 plus. Oxide is a group 6A, so it's O2 minus. So if you combine that to make a neutral ionic compound, it'll combine as aluminum 2, oxygen 3. And then this is a solid. All right, so that is our product, Al2O3 solid. And I guess this description doesn't say it's a solid, but I should really write forms aluminum oxide solid. All right, but I'll just tell you that it's a solid here. All right, so we have our skeleton chemical equation. Now we need to balance those atoms. So, once we write those reactants and products, we can't change the actual chemicals themselves. We don't want to add any more subscripts. So now the only thing we can do is change the whole number coefficients in front of those chemical formulas to balance out those atoms. So I'll just start with aluminum first. So if we take a look at here, aluminum, there's 1 on our reactant side, and if we look at our product, there's 2 on the product side, so a different color. So I'll just put a 2 there in front of aluminum so our aluminums are balanced. Next, let's look at oxygen. There's 2 oxygens on our reactant side and 3 on our product side. So to get those to be equal by using whole number coefficients, if I scale it up to 6 oxygens on each side and put 3 O2 molecules on our reactant side and 2 on this side, on our product side. So then there's a total of 6 oxygens on our product side, and then there's 6 oxygens on our reactant side. So there's 6 oxygens on each side. All right, so then now our oxygens are balanced. But see, I introduced a problem here now. Now I changed the number of aluminums that I have. Now there's 4 aluminums here on the product side. So I can just go back and fix this number in front of aluminum. So I can put 4 aluminums on our reactant side, and now it is all balanced. If you go through it, there's 4 aluminums, 6 oxygens total on the reactant side. There's 4 aluminums on our product side and 6 oxygens on our reactant side. And we have all of our states, so it's all good. All right, so that's one example down. Let's take a look at our next example problem, balancing this chemical equation. So this description says solid sodium carbonate reacts with hydrochloric acid to produce an aqueous solution of sodium chloride, water, and carbon dioxide gas. All right, so we're going to write out our skeleton chemical equation and then balance the atoms at the end. So we need to identify all of the chemicals that are involved in this reaction. So if I go through this, we have solid sodium carbonate. So the chemical formula for that, again, this is kind of practicing identifying ionic compounds and coming up with those neutral ionic compound formulas. So sodium carbonate is Na2CO3. Carbonate is a 2- anion. And it says it's a solid, so I'm going to put solid there. And it reacts with hydrochloric acid. So we're going to add another reactant. So hydrochloric acid is HCl. All right, and then this is aqueous. And it produces, so there's our reaction arrow, it produces an aqueous solution of sodium chloride, water, and carbon dioxide. So aqueous sodium chloride is NaCl, aqueous. Water is water, so it's H2O. And the state of water is always liquid. Although, it says that this is an aqueous solution, aqueous means that this whole thing is in water, but this reaction produces a water molecule. So we're going to say that water is a liquid. And carbon dioxide gas. So CO2 gas. All right. So there is our skeleton structure. Now we just need to go ahead and balance things. So I'm going to just look at sodium here first. So sodium, there's 2 of them in our reactant side in sodium carbonate. And if I look and see where sodium is on our product side, it's right here in NaCl. So there's 2 on the reactant side, so I'm going to put a 2 in front of our sodium chloride product. But now that I've doubled the number of sodiums, I've also doubled the number of chlorides. So now there's 2 chlorides there. So I'm going to take a look at the reactant side, and I see that there's only 1 chloride on our reactant side. So I'm going to put a 2 in front of that. So now the chlorides are balanced and the sodiums are balanced. There's 2 of each. And now I'll take a look at everything else. So I'll look at hydrogen. So there's 2 hydrogens here. And so if I look at our product side, I see that there's 2 hydrogens in our water. And there's no other hydrogens on the product side, so hydrogens are good. And then if I look at what else, other elements, carbon. So there's only 1 carbon here in sodium carbonate because there's an implied 1 in front of sodium carbonate, that's solid. 1 carbon, and then there's 1 carbon in our CO2 molecule, so carbon's good. And lastly, oxygen. Oxygen, so there's 3 oxygens on our reactant side, and there's actually 2 places where oxygen shows up on our products. So you want to count all of the oxygens. So there's 1, 2, 3. So there's 3 oxygens on our product side. So that's balanced too. So again, this is the tip. If an element shows up in more than one place, like in this example for oxygen, it shows up in water and CO2, carbon dioxide, you want to balance that last. But in this case, it's all good and balanced, so there's nothing else that we have to do. This is the full balanced chemical equation for this reaction. Right, so let's move on to the next example. All right, so we have copper 2 sulfate solution reacts with aluminum metal to produce aluminum sulfate solution and copper metal. Okay, so let's identify these chemical names and turn them into chemical formulas first to make our chemical reaction or chemical equation. So copper 2 sulfate. Copper 2 is a 2 plus cation and sulfate is a 2 minus anion. So as a ionic compound, it will be copper, sulfate, just one of each. And here it says it's a solution, so we're going to write aqueous in front of it. And it reacts with, so we have a plus sign, aluminum metal. Aluminum is just an element, and it's a metal, so it's a solid. And it produces, so there's our reaction arrow, all right, and it produces aluminum sulfate, so that's an ionic compound. All right, aluminum is aluminum 3 plus, sulfate is SO4 2 minus. And so how those will combine as a chemical formula that is neutral, it'll be Al2 and SO4, 3 of them, in order for those charges to balance. And this question says that it's aluminum sulfate solution, so this is also aqueous. And then what else does it form? And it forms copper metal. So copper is just an element, and it's a solid because it's a metal. All right, so there's our skeleton structure for our chemical equation. So now I need to check those balanced elements. I usually just start with whatever's first. So copper, okay, I have 1 copper. All right, we might have to come back to that. Sulfate. So see how sulfate is connected to copper here as the anion, and we also have sulfate SO4 here in our aluminum our aluminum sulfate ionic compound. So see how the polyatomic anion doesn't fall apart or anything. It stays as SO4 on both sides. So you can kind of think of it as just like one entity that you need to balance. So I see that there's only 1 sulfate anion on the product side, and on the on the reactant side there's 1 sulfate, but on the product side there's 3 of them because of the parentheses. There's 3 of them. There's 3 there. So to balance the sulfate, I'm actually going to put a 3 in front of copper sulfate. So now there are 3 sulfates there. All right. And then, so the sulfates are balanced. Let's take a look at aluminum. So I didn't have to change anything to aluminum sulfate. I just balanced it with a 3 on our copper sulfate side. So I see there's 2 aluminums here. So I need to put a 2 in front of our elemental aluminum. So there's 2 aluminums on each side. But then because I added that 3 on the reactant side, I now have 3 coppers on our reactant side. So I need to go back to that first thing we did and stick a 3 in front of copper here. So then that is balanced as well. So as long as you take 1 element or 1 polyatomic anion or polyatomic ion at a time, you'll see how to balance those. And if you double something else, take a look back at the last thing that you balanced and just make sure that all those atoms are accounted for. All right, so you can double check your work. 3 coppers on each side, 3 sulfates, 3 sulfates, and 2 aluminums. Great, so this reaction is balanced. All right, let's move on to the next one. Okay, liquid ethanol, and so it gives us the chemical formula, so that's nice, burns in air to produce carbon dioxide gas and water vapor. So this question is an example of a combustion reaction, which we'll learn about when we look at types of reactions at the end of this section. But kind of like when I said the word oxidizes means reacts with oxygen, it's the same thing with burning things. Burning or combustion reactions just means that it reacts with oxygen gas that's in the air, and that's a gas, so O2 gas. So just like what we did with, aluminum oxidizes in air, this liquid ethanol burns in air. So essentially it means that ethanol reacts with oxygen in the air for combustion reaction. All right, so now that you know what burns means, we can go through the chemical equation. So we have liquid ethanol, and they give us the formula. It's C2H6O, and it's a liquid. And it burns in air, which means means it reacts with oxygen gas, and it produces, so there's a reaction arrow, carbon dioxide and water vapor. So CO2, which is a gas, and water vapor. So water is H2O. Vapor, when talking about water, means gas. All right, so there's our skeleton chemical equation. Now we need to balance the atoms. With combustion reactions, there's a specific order that you want to follow. So with combustion reactions, just a little hint, because here you see that oxygen shows up in a bunch of different places, you want to balance the oxygens last. So with combustion reactions, you want to balance the carbons first, and you balance the carbons with CO2, because CO2, carbon on the product side only shows up in CO2. So balance your carbons first with CO2. Then you want to balance your hydrogens next, and you'll balance that with your water. But the most important thing is you want to balance your oxygens last. So those are the rules for combustion reactions. And then when you balance oxygen, sometimes you might need to put a fractional coefficient in front of oxygen. And so if there is a fraction in front of oxygen, you'll just multiply all the coefficients by 2. So sometimes it'll be a fraction coefficient. And I'll show you what I mean. Is this an example? This is not an example of one, but sometimes there will be a fractional coefficient. And if it is, then you want to multiply everything by 2 at the end to make sure everything is a whole, all the coefficients are a whole number. Coefficient. Okay, so let's go ahead and balance those atoms. So I'm going to look at carbons first. So I see there's 2 carbons. I'm going to move this down. There's 2 carbons in ethanol. So I'm going to put a 2 coefficient in front of CO2. So now the carbons are balanced. Now if we look at hydrogen, there's 6 hydrogens. And then so if we look at water has 2 hydrogens per 1 molecule. So to get 6 hydrogens total on the product side, we need to put a 3 in front of water. So see, now that there's a 3 coefficient, 3 water molecules, there's 2 hydrogens per water molecule. This is a total of 6 hydrogens. Now, if we look at oxygen, so there's a couple places where oxygen shows up. There's actually a lot. So what the best tip here is to count up all of the oxygens on the product side, because we're kind of done balancing the product side. So there are 4 oxygens in CO2, and there are 3 oxygens coming from water. So together, there's a total of 7 oxygens on the product side. But then if I look over here on the reactant side, there's 1 oxygen coming from ethanol, and then there's 2 in our oxygen molecule. So it's this oxygen molecule. We want to put a coefficient in front of this oxygen molecule in order to bring our total up to 7 on our reactant side to match the product side. So we need 6 oxygens in order to bring us up to 7 oxygens on the product side. So if I want 6 oxygens total, I'm going to put a 3 in front of our oxygen molecule. And so now everything is balanced if you check everything out. 2 carbons, 2 carbons. 6 hydrogens, 6 hydrogens. And then oxygens, there's 1, 2, 3, 4, 5, 6, 7. And then if you look at our reactant side, there's 1, 2, 3, 4, 5, 6 from this guy. And then 7 from our 7th comes from ethanol. So in this little, hint for balancing combustion reactions, so balance your carbons first with CO2. When you balance your hydrogen second, you want to balance that with H2O. And then balance your oxygens last by putting a coefficient in front of O2. to make sure that you have the same number of oxygens on each side. So there's the hint for combustion reactions. So let's do another balancing a chemical equation for combustion reaction using those exact steps that I showed you. So here we have a different combustion reaction. Gaseous butane, C4H10, in a lighter reacts with oxygen in air with a spark or a catalyst to produce carbon dioxide in water. So if we write out our chemical equation, we have C4H10, that's butane. It's a gas in a lighter, reacts with oxygen. It's burning. We're burning butane, like in a butane lighter or something. So it's reacting with oxygen gas, and it's producing CO2 and water, just like in our previous combustion reaction example. All right? Okay, so there is our skeleton chemical equation. So now we need to balance things. So again, balance carbons first using CO2. Balance your hydrogens next using water. And then balance your oxygens last by putting a coefficient in front of your oxygen molecule, or your diatomic oxygen on your reactant side. So let's go through it. So carbon. There are 4 carbons in butane, so I'm going to put a 4 in front of CO2. Next is hydrogen. So there's 10 hydrogens on the reactant side, and there's 2 on the product side, 2 hydrogens on the product side. So I'm going to scale that up to 5, a coefficient of 5 in front of water. So 5 times 2 is 10. 10 hydrogens. So now we have 10 hydrogens on the product side. So hydrogens are good. So we did carbon, hydrogen. Now it's oxygen. So oxygen, count the number of oxygens on the product side. So here there are 4 times 2. So there's 8 oxygens from CO2. And then there's 5 oxygens from water. And so if you count that up, that's a total of 13 oxygens. All right? So if we look at the reactant side, we need to have 13 oxygens on the reactant side as well. So to get 13 oxygens, we actually need, so since oxygen gas, the molecule comes in a pair of 2, we need 13 divided by 2 oxygen molecules. So what I usually do is just put 13 over 2. That's our coefficient in front of our diatomic oxygen because there's 2 of them. So if you multiply 13 over 2 times 2, because there's 2 oxygen atoms per 1 molecule, then you'll have 13 atoms total. And so all your atoms, carbon, hydrogen, oxygen, would be balanced. But because we don't want a fraction coefficient in a chemical formula, we want to multiply all the coefficients by 2 in order to make that fraction go away. So we would rewrite this balanced equation as 2 C4H10 gas plus, so 2 times 13 over 2 is just 13 O2, gives us 8 CO2s and 10 H2Os gas. And so there is our balanced formula, or balanced chemical equation. So we can check all those numbers again, numbers of atoms. So now carbon, there are 8 carbons total on our reactant side, and there's 8 carbons total on our product side. Hydrogen, so 10 hydrogens, but times 2, there's 20 hydrogens now. And so if we look here on our water side, water has 2 hydrogens times 10, there's 20 hydrogens, so that's good. Finally, oxygen. Oxygen, there's 10 oxygens coming from water, 10 oxygens, and then there's 16 oxygens coming from CO2. So together that's 26 oxygens. And then if we take a look on our reactant side, 13 O2 molecules. Ooh, I forgot that that's a gas. There are also 26 oxygens. All right, so we're all balanced. So in this example, at the very end, we see that we got a fraction coefficient in front of oxygen, but that's okay. If we just multiply all the coefficients by 2, we can get rid of that fraction. But again, if you just follow the same steps that I outlined up here for combustion reactions, always balance the carbons first using CO2, then balance the hydrogens using putting a coefficient in front of water, and then balance your oxygens last by putting a coefficient in front of O2. And then sometimes if there's an odd number of oxygens on your product side, then you'll need a fractional coefficient in order to make your oxygens balanced. And if just keep that, it's okay if it's a fraction, just at the very end, once everything is balanced, just multiply everything, all your coefficients by 2. So let's work through this chemical equation, balancing this equation. So I've given you the skeleton chemical equation. Now it's just up to you to balance those elements. So I'll just go through my typical steps. I usually just go left to right. Students sometimes ask me, like, how do you know where to start? I don't know where to start. I usually just start with the first element and then just keep going until it's balanced. So I'll take a look at nitrogen here first. Nitrogen, there's 1 on the reactants, 1 on the products. So we don't have to balance that yet. You might have to come back to it if we start changing stuff. Next is hydrogen. So hydrogen, there's 3 hydrogens on the reactant side, and there's 2 on the product side. So if I scale it up to 6 hydrogens on each side, I can put a 2 in front of ammonia, NH3, so there's 6 hydrogens, and put a 3 in front of water, so then there's 6 hydrogens on the product side too. Great. And so the next element would be oxygen. And typically, if there's like diatomic oxygen or something, or 1 element, you usually balance that one last. So because we messed up our ammonia, we put a 2 in front of our NH3. Now I need to go back and balance our NO, our nitrogens. So there's 2 nitrogens on our reactant side now. So I'm actually going to put 2 to balance those nitrogens. So now the nitrogens and hydrogens are balanced. Now that just leaves oxygen. All right, and so my tip here for oxygen is just count up all the oxygens on the product side. So there's 2 oxygens coming from NO, and there's 3 oxygens coming from water. So together, that's 5 oxygens total. All right, and so to get 5 oxygens on our reactant side, because oxygen, again, comes in a pair, we need 5 halves of oxygen atoms in order for there to be 5 oxygens on the reactant side. So if you check everything, everything is good. So 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. 1, 2, 3, 4, 5, 5 oxygens on the reactant side, or product side, and then 5 oxygens on the reactant side. But the problem is now we have a coefficient, or sorry, a coefficient that's a fraction. We don't want fractions. So although it's balanced, to be completely right, we need to get rid of that fraction and multiply all those coefficients by 2. All right, and so our actual balanced equation would be 4 ammonias, 4 NH3 gas, plus 5, so 2 times 5 over 2, the 2 on bottom just cancels, so 5 O2 gas gives us 4 NO gas and 6 waters. So really, this is actually another combustion reaction. But instead of carbons, it's with nitrogens instead. And it's just another example where, you balance the oxygens last using your O2 gas. And then sometimes it's a fractional coefficient that you need to scale up to get rid of that fraction at the very end. This just comes with practice. So I'll post a balancing reactions practice sheet for you to study for the midterm 2. And yeah, it's just you guys have to practice. All right, so let's keep going. Okay, so this question's a little bit different. Let's just see if these equations are balanced. So how I approach questions like this is just start counting up atoms and see if they don't match on either side. So we're just determining if the equation is balanced or not. So I'm going to look at sodium. There's one sodium, so that's okay. Nitrogen. Nitrogen, there's 2 on the reactant side, and there's 3 on the product side. All right, so this is not balanced. No, it's not, because the number of nitrogens isn't the same on each side. All right, the next one. So with this reaction, we're just trying to tell if it's balanced or not. There's 2 carbons on our reactant side, 2 carbons on our product side. There's 4 hydrogens from C2H4. There's a total of 6 hydrogens on our reactant side. So note that there's 2 places where hydrogens show up, so we have to count all of them on the reactant side. And then if we look at hydrogens here, for C2H5OH, there's 5 hydrogens here, and there's a hydrogen at the end. So there are 6 hydrogens there as well. In C2H5OH, there are 2 hydrogens. So hydrogens seem to be good too. And then lastly, our last element is oxygen. There's 1 oxygen on our reactant side, and it looks like there's 1 oxygen on our product side. So yes, this reaction is balanced. Cool. So this is just an example where, elements can show up in different places. So make sure that you count up all of those atoms when trying to determine if something is balanced or not, that it might show up in more than one place. Okay, so we'll do a couple more questions here. So let's select the correct number of atoms of each element in the following balanced equation. So this equation is balanced. I told you it's balanced. So this first question is saying how many hydrogen atoms are in the products? Okay, so the products are on the right-hand side, and we want to just count hydrogen atoms. So hydrogen shows up here in water. There's a subscript of 2. All right, there's 2 hydrogens per water, and then a coefficient of 4. So 4 times 2, there are 8 hydrogens there. Next, it's the number of oxygens in the reactants. So if we look at oxygen in the reactants, that's on the left side. So it looks like oxygen just shows up in our iron compound here. And so there's just 4. There's 4 oxygens because of the subscript of 4. And remember, there's a 1 implied in front of iron, or iron compound. If there's no number, there's a 1 coefficient implied. And then finally, the number of iron atoms in the reactants. And again, if you look at our iron compound, that's the only place iron shows up. And so there are also 3 irons in that compound. All right. And you can even go ahead and check if this equation is balanced. It is. There are 8 hydrogens on the reactant side, 8 on the product side. There's 4 oxygens on the reactants. There are 4 oxygens from water on our product side. And iron, there's 3 irons in our reactant because of the subscript. And then so this reaction makes iron solid. And there's a coefficient of 3 in front of there. So irons are balanced too. Okay. So the last kind of question we'll work on in this video. So I think we just want to balance these reactions. So let's look at this first one. Again, I usually just work left to right. So I'll start with magnesium first. So I see there's 1 magnesium on the reactant side. On the other side of the arrow, there are 3 magnesiums in this chemical formula. So I'm going to put a 3 in front of magnesium to make my magnesiums balanced. And then finally, magnesium, and then now we have nitrogen. There's 2 nitrogens in a nitrogen molecule, and then there's 2 nitrogens in my product compound as well. So it looks like nitrogens are balanced too. So I don't have to put anything there. But remember, when we don't have a coefficient, it's an implied 1. There's implied 1s in front of there. So if we actually were to, choose the correct coefficients, even though, we don't have to actually put the number there when writing out the chemical equation, the 1 is implied. So all the coefficients would be 3, 1, 1 for this question. All right, and then the next one, so I'll just go left to right. So aluminum, 1 aluminum, 1 aluminum and aluminum chloride, so that looks good. But then chlorine here, there's 2 chlorines, in our reactant side and 3 in our product. So I'm going to just scale that up to 6. So 3 chlorine Cl2s, so there's a total of 6 there, and then 2 aluminum chlorides, so then there's 6 chlorides in our product. But now that I've changed the number of chlorides, I've also changed the number of aluminums, so I'm going to stick a 2 in front of my aluminum reactant. So now everything is balanced, and what's the answer here? 2, 3, 2, so it's this one, the third one as well. Great. So there's a whole bunch of different practice. I'll upload a practice sheet for you guys to practice balancing equations. There absolutely will be there will be one balance the reaction question on midterm 2. So now this last question, I'll just leave the answers here so you guys can do it on your own. So here are the balanced the coefficients to balance these equations. So hopefully you can work those out on your own. These ones are a little bit more difficult. Different atoms show up in different places. All right, so yeah, practice these and watch the next video where we talk about types of reactions.